Hello. So, this represents what will be part one of three for today's lecture on quadratic functions. So, let's start by just thinking about what a quadratic function means. So, the word quadratic here basically just comes from like almost Greek or almost Latin. I probably should have known that before I started this lecture. For square, these are functions that involve a square term, as opposed to linear functions, which involve a linear term. And I think the right way to see one of them in action is by thinking about an example. Let's think about objects in free-fall. And let's see, I know this will be slightly jarring, but there we go. I think that uses the screen space a little better. All right, objects in free-fall. So an object in free-fall has constant acceleration, and physics says the following. So suppose you go up to the top of Hippo, which is 45 meters up. I haven't measured it, and drop a bowling ball. So that 45 meters shouldn't be trusted. The height of this bowling ball as a function of time. Yeah, there we go. Now you can see everything. Is given by the following equation. The height as a function of time is given by some term coming from gravity, which is about -5 meters per second squared times time squared plus an initial velocity, 0 meters per second times time plus 45 meters, where this term comes from gravity. This term comes from the initial velocity. And you drop the ball as opposed to throwing it. And this is just the initial height. So just because I've seen some students struggle with what this means, I'm going to talk about how to evaluate this. So think about the following as just a small aside. Let's try to evaluate this at height equals 2 seconds. That's okay. So, and seconds is often abbreviated to just s. So I'll just plug in 2s, where s is a second. So that is -5 meters per second squared times 2s squared. So there's this first term. So I plugged in 2s for t. The 0 doesn't matter, plus 45 meters. And let's just see what that winds up being. So that'll be -5 meters per second squared. And let's think about, and you know what? What's a second squared? It's a second times a second. So -5 meters per second times seconds. Take that multiplied by 2s times 2s, because that's what it means to square, plus 45 meters. All right, so some things you notice straight away. In this piece, I see division by s twice. I see multiplication by s and multiplication by s. Oh, cool. Those undo each other. Second cancels with second. Second cancels with second, because they're all multiplied together. So that looks like -5 times 4, because that's 2 times 2, meters, plus 45 meters. So that's -20 plus 45. Oh, so you see these meters? Everything has a unit of meters next to it, so I'll factor out that meters. Oh, cool. So that's plus 25 meters. So I just wanted to show something happening with units. So we expected the unit of just distance to come out. So notice that's why there had to be a unit of time squared, so it could cancel with those units of time. Okay, nice. So that's good. Oftentimes, especially when the units all look consistent, and in this case they are, all the time is measured in second, all the distance is measured in meters, we'll write this without units. Sometimes we'll suppress units and just write -5 t squared plus 45. And just know that time is measured in seconds, distance in meters. All right, so that's all like along a side that's not related to quadratic functions at all. It's just how do you read these expressions with units in them. Let's figure out when this ball hits the ground. So what does it mean to hit the ground? Well, the ball hits the ground when the height is 0 meters. That's what the height is. It's the distance from the ground. So you need to solve 0 equals h of t. But what is h of t? It's -5 t squared plus 45. So you need to solve that equation. And you know what? I think that looks like a fairly easy equation to solve. If you want to pause the video, solve it yourself, and then come back, go for it. Let's proceed to solve the equation. I think what I would like to do, not the only thing that you might want to do, is I'll say negative signs are annoying. Let's add 5t squared to the other side, leaving me with 5t squared equals 45. Fair enough. Let's divide both sides by 5 to get t squared on its own. T squared equals 9. We'll take the square root of both sides. And we'll end up with t equals plus or minus 3. And now I'll remember, time is supposed to be measured in seconds. That's the downside of suppressing all the units. You just have to remember at the end to put the units back. T equals 3 is not the answer. T equals 3 seconds is. And you'll notice I just said 3 seconds instead of plus or minus 3 seconds. Let's think about why not minus. T equals -3 is not a valid answer, since before you release the ball, the model does not apply. Right, so what would plugging in -3 seconds mean? That would mean like 3 seconds before you let go of the ball. So this would say that 3 seconds before you even let go of the bowling ball, it has already landed. And before that, it travels up to your hand and then back down to the ground. Excuse me, sorry, I should be like muting myself before I cough. I'll try to do that next time. So when does the ball hit the ground? The ball hits the ground at t equals 3 seconds. And maybe I'll even finish off with more words after you drop it. It being ball. All right, so the bit I want to focus on is this bit where we did some algebra. So the ideas that make that work are why quadratic functions are useful. You can solve them. So a quadratic function is any of the function that has most complicated term looking like a square. F of x equals ax squared plus bx plus c with a, b, and c constant is a quadratic function. Excuse me. Oh, sorry, I'm going to cough some more. Let's pause recording. All right, fantastic. Cool, that's better. So a quadratic equation is any equation with the form quadratic function set equal to 0. So anything that you can make look like ax squared plus bx plus c equals 0. So I thought that those are equations we can solve. And in order to see that there's at least a little bit of subtlety here, let me convince you that the strategy above this strategy of just like doing the same thing to both sides to get t on its own is at least a little bit subtle if you try to apply it in a situation like that. So let's try to solve x squared plus 2x plus 4 equals 1. You know what? I'm going to make this plus 2 a minus 2 just to make it agree with a coming example. So you try to get x on its own. I don't know, maybe you start by subtracting that 4 to the other side. You get x squared minus 2x equals minus 3 by subtracting 3 from both sides. Maybe the next thing you think you should do is, I don't know, get the 2x to the other side. So I end up with x equals 2x minus 3 squared. And then you say, I see a square, so let's take a square root. So you'll end up saying x is plus or minus the square root of 2x minus 3. And maybe you call it good there. But here's a reason that I would definitely not call this good. So what does it mean to solve an equation? When you solve an equation, you've gotten all of the x's on their own on one side, and then the other side just tells you what x is. This does not do that. There's still an x on the right-hand side. So there x is on both sides of this equation. X is not yet solved for. So you need to do something more to figure out what x is. This strategy won't work. Here's a tool, and the strategy that gives you the tool is an extra credit posted for today called the quadratic formula. All right, so theorem. The solutions to any quadratic equation can be written down by a formula, and here is that formula. The formula is that x is equal to negative b, negative the linear term, plus or minus the square root of b squared minus 4, and I'll try to add some color coding, times a times c, and square root all over 2 times a. So here's the fact. The solutions to a quadratic equation are given by this formula. And so let's see this in practice. We can use that formula to solve this equation. Let's solve x squared minus 2x plus 4 equals 0 using the quadratic formula. And let's just remember the quadratic formula. Ax squared plus bx plus c equals 0 is solved by x equals negative b plus or minus the square root b squared minus 4ac all over 2a. And you know what? There are very few formulas in this class that I'll say you absolutely must memorize this formula, because a lot of them you can reinvent on the spot. The quadratic formula is true for a reason. You can reinvent it, but it's worth just knowing that that's the formula for solutions to a quadratic equation. So let's use that to solve this equation. So the first thing that you should notice, so maybe I'll say this instead, before saying first thing you should notice. Pause this video, solve the equation, then come back and join us. Okay, do that now. Okay, good, you did it. Let's come back and go through this solution. So the first thing to notice is you need to have a 0 over here, and you don't. You have a 1. Well, that's not a bad thing. You need a 0 over there. 1 minus 1 is 0. Let's subtract 1 from both sides. That'll give you x squared minus 2x plus 3 equals 0. All right. So now we have a quadratic equation. We have, this tells me that the a is equal to 1, this a. B is equal to negative 2, this b. C is equal to 3. So that's everything I need to apply the quadratic formula. Let's apply the quadratic formula. Oh no, I'm gonna make, this is annoying. One further change. Let's make this a minus 4. That's a -4, then this will be a -5. So my C will be -5. All right, so after having made those changes, maybe pause the video again, solve this equation. Let's see what the solutions are. The solutions are x equals -b plus or minus the square root of b squared. Okay, so maybe I should do -2. All right, -b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is -4, -5, all over 2 times a. And let's see what that is. -2 is just 2, plus or minus the square root of, so let's go over a side and work out what the thing inside the square root is. So -2 squared minus 4 times -5. Let's just figure out what that is. 2 times 2 is 4. That becomes another plus. 4 times 5 is 20. 4 plus 20 is 24. All right, so there's an answer. The answer is 2 plus or minus the square root of 24 all over 2. 24 isn't a perfect square, so we won't simplify this down to like just a whole number, but it does simplify. Let's remember how to simplify a square root. So 24, does that have any perfect square factors? And yes, it does. It has 4 as a square factor. 24 is 4 times 6. Right, 6 times 4 is 24. So that's 2 plus or minus square root of 4 times 6 all over 2. Now that you see a perfect square inside a square root, you can pull that out because square root, well, you can pull that out. The square root of 4 is 2. So that's 2 plus or minus 2 root 6 all over 2. You look at it some more. Oh, look, everything in the numerator is multiplied by 2. The numerator has 2 as a factor. You can divide by that. So you can cancel these 2's with the 2 in the denominator. All of the 2's in the numerator cancel with the 2 in the denominator. So 1 plus or minus root 6. Cool. So one last example to do. Let's solve this quadratic equation. And there are 2 different ways to do it. Again, I'll say, pause the video, go through and solve it. We'll come together in a moment. And this time I'm not going to make any changes. I know that this is the example that I want, I promise. So pause the video. Okay, let's come back. You want to solve that equation? Well, here's one strategy. Let's use the quadratic formula. By the quadratic formula, I'm going to split this space in 2 so that I can do it both ways. Well, we can write down what the solution is. X, well, I guess first you have to get it into the right form. X squared plus 6x minus 16 equals 0. So that'll give us x equals -b plus or minus the square root of b squared, so that'll be 6 squared, also known as 36, minus 4 times a times c, -16, all over 2a. Cool, cool. So far, so good? Let's evaluate it. All right, so double negative becomes a positive. 4 times 16, well, if you remember your powers of 2, it's not so bad. 16 times 2 is 32, times another 2 is 64. So I see -6 plus or minus the square root of 36 plus 64 all over 2 equals -6 plus or minus the square root of. All right, so let's try to do this addition. 6 plus 4 is 10. Carry the 1, so you can imagine the 1 there. 3 plus 1 is 4, plus 6 is 10. So 6 plus or minus the square root of 100 over 2. Negative 6 plus or minus square root of 100 is 10, all over 2. And now let's write down both of those choices. If you use the plus choice, you have negative 6 plus 10. That's 10 minus 6 is 4 over 2. Or use the negative choice. Negative 6 minus 10 is negative 16 over 2. And I guess I have to buy myself just a little bit more space. 2 or negative 8. If you'll pardon me for a second, I need to let some cats in. They were bothering me, so I opened a window for them to go under a deck. There we go. They're past. Excellent. I could have paused for that, but I figured you wanted to see a cat. So let's solve this another way. So here's another solution to the same equation. You want to solve x squared plus 6x minus 16 equals 0. So what I'll do is I'll think about simplifying that left-hand side, x squared plus 6x minus 16. And I'll try to factor it. I'll try to rewrite it in the form x plus something times x minus something. And the reason I've chosen a plus and a minus is because those two things need to multiply together to be negative 16. So, as a quick recap of the philosophy behind factoring, in green, let's think about what would happen if we factored out that right-hand side now. You'd get x squared, first times first is x squared, outside minus x times one of the blanks, plus blank times x. And the two blanks aren't the same. And then finally the last, plus a number times minus another number. So it's minus blank times blank. So the idea is this quantity needs to be the same as that quantity. And so that means they need to agree on the nose. X squared needs to be the same as x squared. It is. That's fine. This constant term down here needs to be the same as 16. So I need two numbers that multiply together to be 16. I also need minus one of the blanks plus another one of the blanks results in 6. So minus blank plus blank equals 6. All right, so it looks like I want a factorization of 16 that satisfies this condition. Well, there aren't that many factorizations of 16. There is 1 and 16. Oh, but negative 1 plus 16 is no good. That equals 15. There's 8 and 2. Oh, that'll do. Negative 2 plus 8 is 6. So let's fill those in. It looks like x plus 8, x minus 2 does the job. So there's the idea of factoring. If you see a degree 2 polynomial and you'd like to factor it, try to find two numbers that multiply together to be the constant term, and which add together to give the linear term. And the whole point of factoring is now you set this equal to 0, and you say, aha, the only way for a product to be equal to 0 is one of the two things has to be 0. So either x plus 8 equals 0, or x minus 2 equals 0, x equals negative 8, easy to solve, or x equals 2. So you get the same solution, which is good because it was supposed to be the solution. Upside and downside of factoring. You can't always factor. So if you try to factor, you might just fail to be able to do so, and you're stuck. You got to use the quadratic formula. It could be that it does factor, and if it does factor, then it's easier. This idea, I think, was much lighter than this idea. Excellent. So this is where I'll break off and stop part 1 of this video. The reason I'm recording this as a separate part is because of technological difficulties resulting in me losing this much of the lecture when I tried to record the first time. So I'll stop here. This will become part 1 of the video. Come back for future parts.